Welcome, everybody. I hope you've been enjoying all the sessions so far, the first week. In the same way, you will enjoy these ones and the many more to come. So thanks, everybody, for being part of this one and join us on this great BIM Harambee Africa conversations. And we hope that really you get great insight of all this conversation happening on a beautiful continent. So I'm going to be your presenter today. My name is Otto Bodenbender. I'm a BIM manager at Bochmann & Partners Architects. We are an architectural practice, an international architectural practice with 6 offices all around, plus minus 250 people. It's been around for a couple of years, and we focus on purely in architecture, but on anything from small to large projects all across the continent. The topic that I'm going to talk today is about the concept of visualization and how we can go from visualization to immersion in the AEC industry. But immersion not from the concept of virtual reality and augmented reality as the hype that is currently going, but into a more broader concept of data immersion. And the big question that I ask myself, and I challenge all of you to think of the same way, is how can we then use new visualization technologies and processes in order to help us to improve our digital assets? And I'm focusing on the word digital assets because I'm not talking about how we particularly can improve how we see things, but actually how can use new and better ways to actually, for the purpose of the final goal, is to create better spaces for people, better buildings, better areas, better infrastructure, and so on. So that's why we came traditionally from this, the concept of visualization, that it was just a plain and abstract exercise separated from a process that we just intend to visualize or represent certain things, to a truly concept of immersion that, again, not just about on the concept of immersing yourself into virtual environments, but actually create a data immersion where then continually across the process, either it's for infrastructure, or the process is for architecture, or whatever, we can make data flourish. Most of us being familiar with this, and even the concept of the 4th Industrial Revolution is something we keep talking a lot. But in essence, what I'm trying to say here is industry in general, it's been through massive amount of changes. And most of these changes are driven by technology and by technology innovations. But a lot of these technology innovations have triggered the disruption of certain processes. And those processes ended up being disrupting the industries as a whole. So as we can see, we keep saying this, in the last 50, 75 years, we have innovated more than in the last 1,000 years. And then I always like to then portray that idea to our industry. So how that acceleration happens within our industry. And it's been happening much more aggressive than we thought, and much more aggressive than our processes are changing. So this chart has been changed already, and it's many more things we should be adding into it. But again, these are new technologies and technology enablers, but yet we're still really far to get this technology to be second nature on our industry and a way of working. So roughly, I do believe I tried to compile all the challenges we currently have in the industry into 2 groups. And I like to say we have a quantity and we have a quality problem. What I'm talking about that quantity, I'm referring to our lacking on infrastructure and development in Africa is massive. And there are completely different type of numbers going around, but according to the World Economic Forum, if we have to put just in a few numbers, is, well, we have to, for the next 30 years, have to be building 25 schools a day, 7 health centers, and 60,000 houses a day in order to cope with what we call the demand. That demand is being defined by certain stereotypes and so on, but that's not really the point. The point is we are so behind in development of infrastructure and built environment where it's supposed to be, especially on infrastructure. So the moment you develop quality infrastructure, then you set up the the groundwork to then allow the economy to grow towards that and future bases and so on. So we have a massive quantity problem. But most importantly for me, we have a big quality problem. Quality, I'm not talking about quality on the technical resolution. I'm not talking about quality materials. I'm not talking about particular quality builds. I'm talking about that there is a shift to be made in the concept of architecture, the concept of buildings, and in the concept of infrastructure. Doesn't help that now we're trying to accelerate the rhythm on which we build. If we keep building the same things we've been building for the last 50 years. Because whatever we build today with the traditional approach, in less than 20 years, will become completely obsolete. Obsolete on its function, on its dynamic ability to change, and so on. So when I'm referring to quality, I'm referring, then we need to rethink what is the concept of human comfort and how buildings and infrastructure helps and being developed towards the goal of human comfort. We need to redefine our concept of sustainability and how, for instance, the United Nations have developed the sustainability goals. That is something that now we as an industry, we need to start looking and developing towards. We need to shift from the concept of, project delivery to project performance. So how we can stop thinking about how quickly we can deliver a building, but how can quickly deliver it, but have a building that we have certain performance goals that it can achieve. How we introduce truly the concept of circular economy within our processes, smart buildings, asset management. So it's so much, and this is again not technology problem, this is conceptual, this is a redefining our built environment ethos and way of operating. So now this is going truly more granular, this is a shift to be made now in terms of we need to take on we need to frame what is a traditional way of thinking, we need to package it, then we need to put it against the wall, we need to try to destroy it completely and understand what is the new way. Today we're talking about the concept of digital project delivery. This is not really, I'm going down focus really into now the technical side of things, but in the same way we got traditional, now we got digital project delivery. Digital project delivery allow us to then create a smarter process that has new deliveries, new methods, new techniques, new tools, and new people that develop it. This is the kind of the same exercise we need to do broadly in the industry to understand, in the same way that now we develop the digital project delivery, what is the new architectural future concept or infrastructure future concept, or what is really the concept of future cities or smart cities. So then the broader question for me is, how can we use new visualization techniques and processes to improve a digital asset? So how new tech related to visualization and data visualization can help us on this task. So I went a little bit back, and what is the concept of visualization? And traditionally, if you say visualization, we come from purely a two-dimensional environment that we just represent X and Y. That's where we come from, and this is where big chunk of the industry still is, because it works, because that's how I've always done it. So that's why we got a geometry X and Y scenario. And this is a fantastic example of 150 years ago. This is, by the way, if somebody is really interested and enjoy well-developed maps, the Brooklyn Foundation had just opened it like 6 months ago, a whole new archive of historical maps that are beautiful. This was done by Richard Edis Harrison. It's fantastic, really beautiful and high resolution. But again, I just use this one just to illustrate the concept of we can take massive spaces, but at the end of the day, we just represent it into an X and a Y and some color coding. Then we evolved from this into our industry, then took that kind of way of working, and we represented into this one that has a beautiful craft shift kind of operation and beautiful techniques, and we got some beautiful drawings. But at the end of the day, it doesn't matter if what we representing has a height, we still show it to the environment and to just an X and a Y. Then from this, we pass then into more automated systems. So we then introduce CAD, computer-aided systems. So the concept didn't change at all. So the concept that is behind this and the concept behind this is exactly the same. It's an X and Y two-dimensional representation of things. And this is where our visualization comes from. At the end of the day, this is still visualization, and this is on its core data visualization. It's an abstract, it's a representation of a system. So also on the shift from this to this, we improved certain things, but also we lost some other tactile and abstract and craftsmanship opportunities in between. And then now today we have something like this. That is interesting is the only thing that it changed between this one, and this one is just the tool. The process is pretty much the same. The concept is pretty much the same. The difference might be that this one was done with a 10 Rand, or let's call it $1 plot 0.3 or something like that. This one was done with a 3,500 Rand piece of pen. But in the essence, the concept is the same. It's still an X and Y representation of things. So then we have this interesting breakthrough in the industry. Now we managed to have, because of technology enhancements, the introduction of a true set axis. Not just a representation, but a true volumetric system, X, Y, and Z. And then I remember some time ago when I have to model a few projects in 3D in AutoCAD. And that was one of the most painful periods of my time, because for the ones that have done it, you would remember how difficult and painful it was to have to rotate UCS and select planes and all that kind of stuff. But nevertheless, this allows us to then start portraying a more holistic idea of a building, of a system, because now we can truly see it as a whole, rather than sectioning this component into lots of different slices of X and Y. So we went from this to then something more involved like this. And now, thanks to all the systems, many available like SketchUp, then allow us to quickly start producing this one, and then speak about materiality, transparency, color palette, better handling of proportions. Then they started optimizing the tool to make it a little bit easier and all that kind of stuff. Then that then opens the opportunity to then start doing these kind of things. Started creating more kind of atmospheric effects. Then with a little bit of image enhancements and all kind of things, we can start portraying an idea better. But in essence, this is still the same concept. This was done on a X, Y, and just Z kind of axis. Then we use it in different ways. We use it to then portray different type of ideas and even to more elegant kind of solutions. But then the shift started happening slowly but surely. Well, then we started connecting in a really archaic way, I would say, still geometry, dimensional information with pure data information. But as you can see, this one still we're living almost like not in a truly hybrid, but actually almost like into just like a vaguely connected databases. Where we have, and this is where most of the industry still operates today, that we have a geometry environment, that we produce massing, building geometry, called system collisions, design verification, visualizations, and spaces. And on the other side, we got this other side, we got then purely data-driven files like project compliance, calculations, quantities, areas, feasibility, schedules, and so on. And this is a good example that, and we still see a lot of this one, and I think it still has a place in the market in a certain way, but what we can see this kind of SketchUp kind of environment. So like, nothing wrong with SketchUp, I love SketchUp, but it's about, we have this just purely 3D, no data-driven geometry. And then on the other side, we got this completely unconnected but parallel duplication of info, not the duplication, but like data that should be related to the project, but the connections are manually created by us. So it doesn't matter, in this case, it's some columns and bin calculation, but we see this a lot. Just an example, you have your 3D model, and on the other side, you got your schedule of areas that every time you change something in one, you have to go manually into the other one and that kind of stuff. So that is a geometry from one side, is the data on the other side, but it's not a connection and a dynamic update into them. Then this is where the beauty starts happening. Well, now we have geometry from one side and we got data on the other side, but we started managing to connect them and started creating the concept of geolocated systems. But now we have geometry that understands his properties, understands his capacities, his relationships, he understands his dimensions, but also understand where it sits. And that contextualization of data and geometry is one of the most important steps, because we finally managed to create more attributes to geometry. And of course, for the Revit users like myself and many of us, or ArchiCAD or MicroStation or whatever, then that's why we all quickly jump into Revit in such an exciting way, because now we've finally started getting the ability to create a wall and make the software understand that it's a wall and understand its properties, its thermal resistance, its mass, its density, its weight, and all that kind of stuff. And then we quickly started being able to shade it. We still, ourselves included, we're still far away from the true concept of explode to the limit these connections, because at the end of the day, we all still have these really well modeled Revit files, but they're lacking so much into quality of data. And we see this as now we've got fantastic Revit files, but at the end of the day, the data portion is just to extract a bunch of, just a few quantities, a few dimensions, a few elements, and a few areas. But there's so much potential out there. So from this, it slowly started growing into more diverse kind of databases and so on. So then it started help us to analyze buildings in a certain way, to compute, to calculate some type of resistance, to calculate some type of flexions, to calculate some type of daylight and sunlight simulations and all that kind of stuff. But this is kind of where we are. And because of this connection, then it truly helped us to start grabbing different pockets of data and truly connected to each other. But we can have specs connected to products, connected to systems, connected to spatial data and elemental data all together, and then dimensional data and so on. And all of this on the true context environment of GIS and BIM systems is where all of this connection can really truly nurture. Reality is we still have a massive problem that most of the project, most of the systems that we currently use, they are truly connected database on its own. But then to be able to connect these databases with a broader spectrum on a discipline is still a massive challenge. What I'm trying to say is they have become really good on each one of us on our own discipline. So then I started creating our own databases connections for our own discipline purpose. So we as architects became really good to then be able to connect our own database systems within ourselves. But we still have within the industry these silo pockets of databases. But these individual silo pockets of databases still doesn't connect well with all the disciplines. And that's a challenge that we still, all of us, we need to address. It's really important how we can go to a more open BIM scenario and open source kind of environment where the architect shouldn't work in isolation in such a way, and neither the design engineers, neither the quantity surveyors, and so on, because we still work in this kind of silo environment. And at the moment we do that, we actually are not just isolating a way of working, but actually also enhancing just one side of a building, where the building doesn't work like that. The building is a holistic system that it needs to be think and develop as a cohesive element. So the question is, we now managed to create that kind of data connection, but we need to start doing a massive shift between the concept of geometry, like a really high density and accuracy geometry with some pocket of data, to a much more aggressive data driven. So it's almost like we need to create databases and then associate it with dimensional data or geometry, rather than create geometry and then just trying to plug certain data into it. And that's a massive shift we need to do, because pretty much doesn't really matter which industry you are today. At the end of the day, we can almost say that all of us, we are on the data, on the data industry, and on the basis of data visualization. Even if you're a lawyer, if you're an architect, an engineer, we all work with data, and data has become now such a common denominator of all other systems. And also data is not about just small pocket of numbers, it's complex interconnections of systems. So it becomes really important that we all understand how can we use, manipulate, connect, and edit data in new ways, and then how we can actually improve our communication and visualization systems in order to visualize data in a different way, and then be able to convert raw data and then create it in make it information, and at the end of the day, create knowledge out of these new connections. So that's why the focus now is how can we enhance data and connections across all our discipline systems, and then find new ways to display that data to help us to do better buildings. So once we have this approach, then our processes can open it up to a whole plethora of new tools, of new technologies, and new processes that are emerging with the fourth industrial revolution. So now we can take more advanced concept of BIM, VDC, and lean construction, and then connect it with incredible and well-developed databases and big data. We can start mining information in a different way. And then we can start using artificial intelligence to then start creating meaningful relationships between those data and projections. Then we can also start connecting this one with the Internet of Things to start reading how our buildings react and how infrastructure reacts and change over time, and then how we can take all of that information and then highlight the one that will need at each particular time of the process, and then use virtual reality, augmented reality, immersive context, XR or whatever, to then display it. So I really like the sentence that I came across the other day, that it says, the greatest value of a picture is when it forces us to notice what we never expected to see. So it's really particular for pictures in this particular case, but take the word picture out, and it says the greatest value of data visualization is when it forces us to notice what we never expected to see. So the question is here, we are on this massive drive and hype, technology hype at the moment, of trying to embrace new technologies because it's the cool thing to do, because it's a new virtual reality tool, augmented reality, and those. And I think we all been playing with those things, and it's extremely exciting. Nevertheless, it's really important to understand what is the real value that these new technologies or process can help us within our process. So the question is, what are the questions that these new technologies help us to answer beyond the hype of things? So then I just started with a few questions, that this is the one that personally helped me to understand what are the place of these new technologies, and what are the questions that we have at the moment that we need clever solutions, and how this tech can help us. So one of them is, like, I was thinking, how then can we use technology to create more immersive experiences, to then connect better with a broader spectrum of users? So how can we now, we as designers of infrastructure systems, of buildings, or spaces, understand that the final goal of a building is the final user? And that final user is not necessarily the one actually paying for the building, but rather the 5,000 people that is going to use the train every day, or the 1,000 people that is going to interact with this building within a week, and so on. So how can then we reach a final user, that is the people that really will experience this new infrastructure or this new building, and understand the feedback, understand the frustrations, the goal of the initiatives? So how can we use then technology to democratize the access to that? This is a really interesting example that we have, that I found come across. So it's called Hawaii Housing Lab. This is a project done by KPF. It's a beautiful initiative that has been tasked to the idea to actually conceptualize the future neighborhood concept for Hawaii and how it will develop. And then the first thing they thought is, okay, first we need to understand what is the people's idea, and how do you like to live, how they project themselves in a future smart city, and so on. So through a really kind of simple technological approach, using different solutions, from a super no tech at all kind of just physical stand that is just capturing people, to then more complex tools that they have created, this interactive cloud-based tool that anybody can access from the phone, from a laptop, from a tablet. And this one is actually a really complex system of connected databases on the back. This one has lots of statistics and user and regulations and so on, and they put it into a cloud-based parametric system that now every Hawaiians, and if you say like that, any citizen of Hawaii, they actually could approach this place that is painting their idea of a future neighborhood. How do they like it? What are the values they project the most? What are the things they enjoy the most? And then certain new technological improvements like cloud-based systems, computational design in a particular way, artificial intelligence and big data connections allowed all of this to happen. And the most beautiful things for me is, like, at the end of the day, they got a feedback from more than 10,000 people on how they envision, how do they envision this future way of living. And they're going to be the final users. So they're the ones that actually, if you take them out of the equation, this could be a massive failure. Like we have seen in some of the, like we have seen with modernism, that we put certain aesthetic and functional things above the way people experience with buildings. And at the end of the day, we derail the purpose of architecture. Another example is then, how can then we simulate user experience better in order to gather meaningful data on design stages? So what if now, I mean, particularly on buildings, we can then present people with different spaces, and they can experience it, they can understand, and then they can give us immediate, rapid feedback right on design stages that allow us to then fit the building better to the people, rather than have to fit the people to the building. So this is a home example that now we put different clients and different perspectives into these immersive environments. We show them different parts of the building, and they can actually interact and change different things. And this is one a completely kind of virtual reality environment that we show them. This will allow us to do a building that will fit the purpose better on certain commercial aspect, tenant aspect, and environmental aspects as well. So this was a really interesting example we did, and this was a massive virtual experience with like 5 different headsets going around. Another example, another question is, then how can then understand and gather current and future customer needs as well using technology? So this is now another example of how can we reach 1,000 people again, and kind of ask them and test it with different ideas for us to understand better what are the things they're looking for. And I love this one because it's a completely kind of low-tech approach. This is not the one that we need to break the bank, and we're talking about 10,000, 15,000 rand piece of equipment. We're talking about just 100 rand, less than $5 kind of piece of technology that allow us to just democratize the access of our designs. Rather than actually just designing for the 1%, now we can design for the 99% and ask them what they think about the built environment. So what they think now the future bank is. So this is a presentation we have done some time ago, and then we took that approach. We exposed a lot of people to this one, and this was a completely virtual reality or desktop-based experience that you go through a whole different range of ideas, and then you can actually now select the ones that interest you the most, the ones you agree, the ones you don't agree, and how you envision, in this case, the future of banking. Or another more simple example is then how can then bring and democratize access to a remote site location that is 7,000 kilometers away with just incredible low-tech 360 camera and just a simple platform that allow us to connect all together. And this one, it gave us then on the notion of time, the notion of progress, and now we've got an entire team be able to access the information. Then another question is, then how can then we use new technologies to then capture and visualize as well remote sites? And this is the notion now of photogrammetry that I think we all been exposed lately. But within infrastructure we've seen this a lot, and also now in our case in architecture we have done a lot as well for a couple of years. And this is a project we did almost like 3 years ago, where it was a really extremely remote, far away site from our offices, but we still want to understand the site and its environment and its virtue. So just with a low tech and simple takeoff, just a simple drone, then we took a bunch of pictures, and then through different photogrammetry process, then allow us to recreate the site with a pretty good accuracy that we needed for the particular design stage that we were. So this one was right early on the concept design of the project that allowed us to get a really good grasp of what are the scales, the proportions, the palettes, the areas of this particular site. And since then, since 3 years ago, this is standard practice on all our projects to then be able to create this kind of digital capture of the site that help us, all this data help us from the get-go to get much better information to then inform our design processes. So again, this is about how we can use new ways of, in this case, data capturing and data visualization to improve the acquisition of site information. And of course, then using other technologies that is connected now with photogrammetry, in this case, augmented reality, we then managed to take this photogrammetry model and just with a simple phone, nothing fancy, then we created an app that allows us to just quickly take photogrammetry models and put it within our desk. So this one was under the desk, and then a group of designers, just a couple of minutes after, they have access to these augmented reality models on desk. And we can use this information to then start the design from the get-go with a much solid foundation. This is another example then also then how we use now a combination of different technologies and data visualization technologies, in this case, augmented reality, but also 3D printer. At the end of the day, 3D print is another way of data visualization. It's almost physical data visualization. And this allows us to then put multiple systems together, from 3D printer to 2D drawings to 3D models and augmented reality models, to then be able to have much better decision-making process because we got much better information at our fingertips. Another question is then how we can improve construction processes using latest XR technology. This is something we Googled recently, and I think it's really exciting. It's great development done by Trimble. It's called Sidevision. This one in particular takes now your geolocated models through GIS systems and infrastructure, and then allow us through simple device that now is connected to the internet and has GPS connection with coordinates, allow us to then quickly be able to project your models on the real side and the real position. Now, it is interesting for me that lots of people that I show this one, they're still crazy about like, oh, look at all the geometry. But what is interesting for me is the geometry in this particular case that you see on that cell phone is almost like just the small front end 1% of the things. But behind that little blue box is a 99% of databases connected that understand dimensions, positions, coordinates, relationships, and so on. So this is something that we can never get to that part of this kind of technology in the process if first we don't build accurate data models. And for me, the data is not about the geometry, the data is about the dimensions. So the accuracy is not about the geometry, the accuracy is about the data. We need to produce good databases and then attach them with geometry. And this is a good example that then after you do that, after you create these great databases that allows you to then display it in such a way and streamline your entire setting out inside on a tenth of a fraction that it will take you just with traditional drawings. And also this is more local example for us. So then how through small little enhancements and technology applications, then we allow us to then just facilitate and be able to facilitate the construction process just by be able to provide accurate information when it's needed. So in this particular case, in the case of a shop fitting that we have designed, not just about by including just 3D visualization components within the sheet. So now the shop fit, you can see the system as a whole rather than this sectioning kind of scenario, but also through the incorporation of QR codes, as we can see there, that now through our application that we develop, just by scanning that QR code, then you can actually just quickly see on augmented reality connected to the drawing how that shot fitting comes and how it's integrated, or which part of the system comes with it. And then also you can take that one into a one-to-one scale, as I've done it, and then put it on the real site and the real position that it needs to go. Then this is not far, then if you keep developing going further, to then be able to take this one and use the very same augmented reality models as setting out coordinates for the true construction of it. And then last but not least, then how we can find new ways to connect and visualize data to enrich decision making. So, and then we can actually just forget a little bit more about the geometry and focus way more on the data. And this is an important one for me because it shows, thanks to all the developers, like in this case, Power BI, then it really allow us to then start making the data flourish among the geometry. So this is the case of, this is a development done by VCAD that allows you to take Revit files and then plug it into Power BI and see Revit files in a completely different way. This is something that should have been done many years ago just on a native software, but now we can actually start seeing our files as a truly databases rather than just geometry. We can start exploring all the connections that information has, and I started taking all the data, creating meaningful connections, and converting that data into knowledge. This is another example more internally for us, that now we created an automated system that allows us to then review multiple models within a week automatically without human intervention, and then be able to report weekly what is the status of all these Revit models. But this is something that is, the question here is not about the particular numbers that we see here, but how all these numbers can tell us new meaningful information, can help us to improve the way we do things. And then lastly but not least, is we got here another great example from Otto, this project Dasher 360, that then is now taking that dimensional X, Y, and Z, connecting it with data, and then connecting it with time and sense and Internet of Things. So now we just not see the geometry and the data, but now we see how things change with time. And then most importantly, when we add live connection to Internet of Things and sensors, now we can see how structures and buildings react with time based on human intervention. And now we can make our buildings adapt better to our needs rather than us adapting to a built environment. So this is another example. Please go and check this project because it's extremely interesting. So at the end of the day, let's go back to the principle. We've got a great challenge ahead of us, that is a quantity and quality. I would first like to focus on quality, how we can make things better. And after we manage to achieve and raise the standard, then how we can make it faster. And how we can all embrace these new technologies, but understand the meaning that each one of them can have on an individual process to help us to do better buildings. So that's all from my side. Thank you very much for listening to me talking for 40 minutes. I hope you enjoy it, and looking forward to see you all in the next sessions. And I hope you have a great weekend. Thank you very much. Bye-bye.